Hello everyone, welcome to our online video tutorial series. Today we will discuss about class 11th topic relation and functions. Dear student, in this video lecture we will learn about the Cartesian product between two sets. So let's start today's class. First we will understand that what do we mean by the Cartesian product of the sets. Dear children, I think that you are aware with the ordered pair. See, in class 10th also we plotted some graph of Cartesian coordinates. For an example, if I write 5 comma 7, then most of you will get the idea that 5 belongs to the abscissa, that is the x coordinate, and 7 is the ordinate, that is the y coordinate. So how you got this idea? That means they are written in that particular order. That's why it is known as the ordered pair. So suppose P is a set of two colors and Q is a set of three objects. So P is a set of two colors, red and blue, whereas Q is the set of three objects, B, C and S. What is B, C and S? B represents bag, C represents coat and S represents shirt. Okay, then how many ordered pair we can make? So to get that, I draw a diagram here. This axis representing the colors red and blue, while this axis is representing the bag, coat and shirt. This should be S. So now how many ordered pair I can get? I can make a red color shirt, red color coat and red color bag. Similarly, blue color shirt, blue color coat and blue color bag. So that is to be written like this. Red color, then bag. Red color, then coat, red color, then shirt. Similarly with the blue one also. So these are known as the ordered pair, or if I list all these ordered pair, that is known as the Cartesian product from the set P to Q. This is known as the Cartesian product from the set P to Q. Means first we will select the elements from the set P, which are the indicating colors. Then we will select the second element from that ordered pair will be belongs to second set, that is the bag, coat and shirt. So till now we got a basic idea that how to write the Cartesian product. Okay, let's define it. Now two non-empty sets P and Q, the Cartesian product P to Q is the set of all ordered pairs of the elements from P and Q. That is set of all ordered pair. So in this set we will write the ordered pair as an element, where first element P belongs to the set P and the second element Q belongs to the set Q likewise. So you can check it here that first element in all the sets belongs to the first set, that is the red or blue. And if I'm talking about the second elements, then second elements belongs to the second set, that is Q. So in that order we have to write down. So it is the set of all possible ordered pairs. So if either P or Q is a null set, then P cross Q will also be an empty set. That means then their Cartesian product will be equal to an empty set. So let's do here. G is 7, 8 and H is 5, 4, 2. Find G Cartesian product with H. So let's do that. It means that we have to take the first element from the set G. What is that? 7. And 7 can be related with all these three. That means 7 with 5, 7 related with 4 and 7 related with 2. Similarly, we can relate the 8 with all these three elements. So it will become 8, 5, 8, 4 and 8, 2. And if I am writing H Cartesian product with G, then how to write down? Then I have to take the first element from the set H. That means these elements belongs to set H will be written first. So that 5, then second element will belongs to set G. So let's take second element. 5 can be related with 7 and 5 is to be written with 8. Similarly, 4 is to be written with 7 and 8. And 2 with 7 and 2 with 8. Dear Children, here I would like to tell you that 7, 5 and 5, 7 are not equal, because if I draw them, see 5, 7 means this coordinate first set is 5 and coordinate from the second set is 7. So this is 5, 7, and 7, 5 will be a different ordered pair. So they are not equal to ordered pair. A comma B and C comma D will be equal if and if only A is equal to C and B is equal to D. Only in that case they may be equal. So here A cross B is equal to this. Then find the set A and B. This time we have to separate the set A and B. Okay, we know that first element belongs to first set. And what is the first set? A. So check the first elements of all the ordered pair. So it is A, then again A, I will not list here, then B, yes, again B, need not to list, yes, A comma B. And if I am talking about the set B, that is the second set in the ordered pair. So second elements we will list, this is X and Y. So A and B sets are like this, okay, and Cartesian product of A and B is given here. State whether each of the following statements are true or false. If statement is false, rewrite the given statement correctly. Okay. If P is equal to M comma N and Q is equal to N comma N, then P cross Q will be this one. Okay. Forget about this. First, let us find out P cross Q by ourselves. P cross Q. So means first element belongs to set P and the second element belongs to set Q. So M is to be related with these two elements first. So M with N, M with M, correct? Then N is to be related with these two elements, that is N with N and N with M. So are they equal? No. So it's a false statement, it's a incorrect statement. So one more thing you can check, that if number of elements in P is 2, number of elements in Q is 2, then number of elements in P Cartesian product with Q will be 4, correct? Here it is 2, here it is 2, then its Cartesian product will have 4 elements. If A and B are non-empty sets, then A Cartesian product with B is a non-empty set of ordered pair X and Y such that the first elements belongs to first set and the second elements belongs to second set. Correct here? Because here we are writing A Cartesian product with B. That means first element will belongs to set A and second element will belongs to set B. And the same thing is written here. So it's a correct statement, true statement. Next, if A is equal to 1, 2, B is equal to 3, 4, then A Cartesian product with B intersection phi. Okay, what will be B intersection phi? In the previous chapter, we read that intersection with an empty set is always an empty set. So B intersection phi is an empty set. Let's find out the value of A cross B intersection phi, that is empty set. And we read that in the properties that Cartesian product between an non-empty set will be a non-empty set, but if we do the Cartesian product with an empty set, our answer will be an empty set. So yes, it is a true statement, correct statement. So let's understand the properties of Cartesian product. Two ordered pair are equal if they have corresponding first elements are equal and second elements are also equal. I already told you that A comma B will be equal to C comma D if and if A is equal to C and B is equal to D. So here x by 3 plus 1 will be equal to 5 by 3 and y minus 2 by 3 will be equal to 1 by 3. So x by 3 will be equal to 5 by 3 minus 1 and y will be equal to 1 by 3 plus 2 by 3. So the value of x will become x by 3, 2 by 3 and x is equal to 2. Similarly, value of y will become 1 by 3 plus 2 by 3, 1. So these are the values of x and y to make these two ordered pair equal. Next property is, if there are p elements in set A and q elements in set B, there will be pq elements in A Cartesian product with B. Okay, That means if number of elements in A is P, number of elements in B is Q, then number of elements in A Cartesian product with B will be PQ. So set A is having 3 elements. The number of elements in set A is 3. And set B is having how many elements? Count them. Cardinal number will be 3. Then find the number of elements in A cross P. So that will be equal to number of elements in A, number of elements in B. So 3 into 3. How many elements it will have? 9. It says that if A and B are non-empty sets and either A or B is an infinite set, so is the A Cartesian product with B. See, if A and B are non-empty set, then either A or B is an infinite set. Then their Cartesian product will also be an infinite set. For an example, if I do the Cartesian product between the set of natural numbers n to n, so n infinite number in this set, infinite number in this set, so their Cartesian product will also have infinite number. Properties of Cartesian product. Next is, so here it is an ordered triplet. Actually, this is a Cartesian product between 3 sets. Then the first element will belong to first set, second element will belong to second set, and third element will belong to third set. So A comma B comma C. Now we have to write the 3 elements in that particular order. So here A comma B comma C is called the ordered triplet. Let's do one problem based on that. If A is equal to 1 comma 1, then find A Cartesian product with A, Cartesian product with A. So first let us find out A to A. What is A? A is minus 1 comma 1. Okay. Again I am writing once again so that it will become an easy task for us. So now do the Cartesian product between these two. So it will give you first element of the first set and ordered pair with all the elements of the second set. So minus 1 with minus 1 and minus 1 with 1. Similarly with the second element 1 comma minus 1 and 1 comma 1. So this is my A Cartesian product with A. Now let's do A Cartesian product with A and A. So this become the second element. Okay. So now it will become first I have to take from this one and second element I have to take from this set. So if I take minus 1, then I have to write with this. Don't miss the order. Then minus 1 is to be write with remaining 3 ordered pairs. So minus 1 with minus 1 1, minus 1 with 1 minus 1, and minus 1 with 1 and 1. Now 1 with all the 4 ordered pair. So 1 with minus 1 and minus 1. So 1 minus 1 1 and 1 1 1. So how many elements this will have? 8. The reason number of elements in 2 is 2. Number of elements in 2 again in 2. So total will become 8. So you can check that how many ordered pair we got. 1, 2, 3 and 4. Again 4, that is 8. Next is A is 1 comma 2, B is 1, 2, 3, 4 and C is 5 comma 6 and D is 5 comma 6 comma 7 comma 8. Then we have to verify this. What is that? So let's understand this, what he wants to get it verified. This is a distribution of Cartesian product over intersection. So A cross B, then sign of intersection, then A cross with C. So let's do the left hand side first. Left hand side. Left hand side we need A Cartesian product with B intersection C. So first let us find out B intersection C. B intersection with C. This is B. And if I do the intersection with C, how many elements are common? Empty set 5. And then A Cartesian product with 5 will be equal to an empty set. So this is my left hand side. Let's do right hand side. Right hand side I need A Cartesian product with B and its intersection with A Cartesian product of C. So let's find out these two parts first. A Cartesian product with B. So it will become 1 with B if I do 1 and 1. 1 2, 1 3, 1 4. Similarly with 2, 1, 2, 3 and 4. Now A Cartesian product with C. So first I will write down the elements of A, then elements of C in the ordered pair. 1, 5, 1, 6, 2, 5 and 2, 6. Now check that. Is any pair is common between them? 1, 5 available here? No. 1, 6? No. And no. Nothing is common. So I can declare that A Cartesian product with B intersection with A Cartesian product with C having nothing in common. So from 1 and 2 I can say that both are equal. So A Cartesian product with B intersection C is equal to A Cartesian product with B intersection A Cartesian product with. Okay, similarly we can check that A Cartesian product with C is a subset of B Cartesian product with D. So first find out B and D and then find out A Cartesian product with C and check whether that all the elements of A Cartesian product with C are the available in this set. Let A and B are the two sets such that number of elements in A is equal to 3. Number of elements in A is equal to 3. Number of elements in B is equal to 2. Okay. If x comma 1, y comma 2, z comma 1 are in A cross B, okay, find A and B where x, y, z are the distinct elements. These are the parts of A Cartesian product with B. Actually, as per rule, how many elements should be there in A Cartesian product with B? Number of elements in A, number of elements in B. So these are 3 and these are 2, so there should be 6. And how many are written there? Only 3 are written. So remaining 3 are missing. So we have to find those 3 first. For that, let's separate A and B. A is what? A is the first set in that ordered pair. So all the elements first or elements of the ordered pair will belong to set A. So X belongs to A, then Y belongs to A and Z belongs to A. Okay, so this is A. Now what is B? B is the second set in this Cartesian product. So elements of the second elements of this ordered pair will be 1 and 2. So now if I complete that A Cartesian product with B, it should be X with 1, X with 2 and Y with 1, 2, Z with 1 and Z with 2. So this is the complete Cartesian product between these two sets. We have to find A and B. So these are A and. So that was all about Cartesian product. In next video we will learn about the relations. Hope you enjoyed this. Thank you very much. Happy learning.